Hello. So, this segment we are completing the square. Hooray! So, to complete the square, right, remember the sort of first thing that we need is to make sure that we have what's called a monic quadratic, which means that really what we want is that the leading term is 1. Meaning if I have any kind of leading coefficient, leading coefficient is 1, leading term includes the x squared. Anyway, if we have a leading coefficient that isn't 1, like here we have a negative, right, then we have to factor it out before we do anything else. So in particular, my p of x, right, this is equal to negative of, and then I have x squared minus 18x plus 76. Okay. Now I can actually start the completing the square process. So that says, okay, take the coefficient in front of the middle term, right, the x to the 1. So take that coefficient, so off to the side, maybe I'll do it in a different color so it's clear. Just off to the side, I'm like, okay, I have minus 18. Cut that in half, so divide by 2, that gets me minus 9. I'm going to need that a little bit later, so I'm going to write that, just leave that there. But then I want to take that number, minus 9, and square it, which gets me, in this case, 81. Okay, right. 9 times 9, 81. So what I'm going to do is I'm going to add and subtract that 81. So I still have the negative just sort of sitting out there. I have an x squared minus 18x. But now I'm going to add 81 and then subtract 81. And then I still have that 76. Okay. And the reason I do that, and in particular I added first, that is personal preference. You don't have to add first. You could subtract, but I like to add first because that makes these first 3 collapse into a perfect square. So I end up with, so again, that negative is sort of factored out. But I'm going to end up with x plus that half number I just got. So it's x plus minus 9 squared. And that's what all of these collapse down to. And to be clear, you don't have to memorize that it's that number. It's just sort of helpful to notice, because really you could just take that set of numbers, right? You could just take this x squared minus 18x plus 81 and do a factor by using coefficient method and be like, all right, what's 2 numbers that multiply to 81 but add to negative 18? It's negative 9 twice, right? But then I still have this bit out here. So I still have the minus 81 and the plus 76. Now, strictly speaking, my completing the square step is done, but it is sort of assumed that when you complete the square, you give it back in vaguely the same sort of format that you had it in. So I know I'm big on don't do extra steps unless you have to, but it is sort of the expectation. And so with that in mind, I will pretty much guarantee you, right, that if you have one of those looking at complete the square on an exam and it's multiple choice and you have to figure out which one of them is the square, is the right answer, it's always going to be the sort of put back together. So I'm going to do that part as well. So the first thing I'm going to do is just put these 2 things together. So I'm going to have negative x minus 9 squared, right? So I don't have to worry about the parenthesis. Minus 81 and plus 76, that's minus 5. And then I'm going to distribute the a term, which is just the negative sign, back in. So I have negative x minus 9 squared plus 5. So again, by convention, when you're asked to complete the square, or when you are going to complete the square, you sort of put it back into this format because this is vertex form. And if you remember that, we're not going to really worry about the naming of these things. But that's sort of one of the primary reasons we always did completing the square. And so it's sort of always assumed you put it back in that format. So that's what I'm going to sort of call the end, even though technically we finished back up here. Okay. So again, just as a quick run through, we started with the thing where we need to have a leading coefficient of 1. We had a negative sign, so we factored that out so that I have, just a 1 there. Right, so to be clear, I have just a 1 right here, right? Then I took half that, right, negative 18, divided by 2, I got negative 9, squared it, got 81, add and subtract 81. That lets me collapse those first 3 into this x plus the negative 9. That leaves the leftovers, negative 81 and 76. combine those to get -5, then distribute the negative. Okay. So that's that. Hello. So in this video, we are completing the square. So to complete the square, remember we want to start out by making sure that we have a monic quadratic form, i.e. that we really just have a leading coefficient of 1 and it's some sort of quadratic. So since this doesn't, I need to factor out the leading term. So I'm going to start by having that my function is -5 times. Now, there's a couple options for how you factor out the leading term. So in one of these examples, I do the thing by just factoring out of everything. But really, the completing the square bit only ever cares about the terms with x's attached to them, right? Like the x squared and the x term. So we could do just that bit and sort of just have the constant tag along for the ride, which is what I'm going to do this time. Just so you see sort of both methods. Whichever one you do is entirely up to preference. There's not really a right and wrong way. Sometimes one of these methods is easier than the other, but again, not always. So factoring out the -5, I'm going to get at x squared. Factoring out the -5 from the 80, I'm going to get -16x. And then, as I mentioned, I'm going to have this -326 just sort of sitting there. So in particular, I didn't factor the -5 out. I'm just having it sort of tag along. Okay. All right. So what next? Well, next I want to take the b term, right? The term that is in front of that x to the 1. I want to take that number. So I'm going to take the -16. I'm going to cut that thing in half. That gets me -8. And then I'm going to take that -8 and square it, which gets me 64. And in particular, I'm going to add and subtract that 64 inside the parentheses because I want it to be sort of attached with the x squared and the x. That gets me -5, x squared minus 16x. I'm going to have plus 64 minus 64. And again, I have the -326 just tagging along. Okay. All right, now what? Well, I did it this way because these three collapse into a perfect square where it's going to be x plus, the number up here. Or again, you can just take these three and be like, okay, what's, two things that multiply to 64, add to -16, it's -8 twice, right? So you don't have to memorize anything, but either way, you'll get there. So that gets me x minus 8. And in fact, let me maybe color coordinate this a little bit better. So I'm going to have x minus 8 squared. That leaves me the -64 still. Minus 326. And again, this is technically where we have completed the square. We have done the step, but by convention, we always expand out again and combine like terms and simplify. So I'm going to do that because that's almost surely what you'll have to do in every time that you need to complete the square. Almost certainly you're going to have to do those steps afterward anyway. So here I'm going to multiply out the -5. So I'm going to get -5 x minus 8 squared minus 5 times -64. So -5 times 60, or -5 times 6 is 30. Add the 0, so that's going to be 300. -5 and 4, so that's going to be 320. Minus 326. And then simplify. So I'm going to still have -5 x minus 8 squared. 320 versus 326. They're off by 6. The negative is bigger, so it wins. So I'm going to get -6. Okay. So again, the actual completing the square step, right? I had to get it so it had a leading coefficient of 1, or I had no visible leading coefficient. Then I took half of -16 square and divided by 2 to get -8. Square that to get 64. Add 64 to both, right? So factored out -5. Use that to figure out I need to add and subtract -64. The -326, I can't forget about it. It tags along, but I don't have to factor out the -5 and get a gross fraction and carry it along. I can just leave it outside until I'm done. Those three right, combine down to this x minus 8 squared, leaving me with just the negative 64 left over. Then I expand out, right? I distribute the negative 5, so I get negative 5 times that first term, negative 5 times the second term, which gets me positive 320. Negative 326 is still tagging along. Put those two together to get that minus 6, and we're done. Okay. So that's that. Hello. So in this segment, we are completing the square. Hooray! So as usual, right, completing the square, what we need to do is start by factoring out the a term, right, the leading coefficient, because to complete the square, we need to have a leading coefficient of 1, right? So since this isn't 1, it's 4, we have to start by factoring that out. Now, I can factor it out of everything, or I can factor it out of just the sort of leading terms. My general rule of thumb is if it goes evenly into the last term, then I'll factor it out. If it doesn't, I'll just leave the last term out. So since this is a 5, I'm dividing by 4. It doesn't work nicely. So I'm just going to do it out of the first two terms to get x squared minus 2x. And I still have that plus 5, right? Now, the next step, right, I need to, now that I have that leading coefficient of 1, the monic polynomial, then I need to take the term in front of x, right, the term in front of the linear term, the coefficient in front of the linear term, or the b term, if that's how you like to think of it. So I take that negative 2, cut it in half, so that gets me negative 1. Then take that value, negative 1, square it, gets me just 1. And now I want to add and subtract to that number. So in particular, 4 times x squared minus 2x. And it's key that I'm adding and subtracting inside the parenthesis, right? If I didn't do it inside, then I get really just something terrible. That would be a bad call. Okay. And again, I do this so that I can take that middle part, right, the x squared minus 2x plus 1, right, with the added part, and I can collapse that into a nice perfect square. So in this case, I have 4 times, then that whole part becomes x minus 1 squared. You can do that with the factoring using the coefficient method, for example, or just sort of notice that's always this thing over here, negative 1. That leaves me a negative 1 left over. Oops. Let's try maintaining my colors if I'm going to use them. That leaves me a negative 1 left over, and then I still have that plus 5 just hanging out. Now I've technically finished the completing the square step, but again, it's always basically going to be the case that you need to sort of simplify this back out. So I'm going to distribute the 4 to get 4 times x minus 1 squared. Then 4 times negative 1 is minus 4. And I still have that plus 5 hanging out. And now I can combine like terms to get 4 times x minus 1 squared minus 4 plus 5 is plus 1. Okay. So again, factor out the leading coefficient so that I have a leading coefficient of 1 that I can deal with. Since it didn't go nicely into the constant or into the c term, then I just didn't. I just let it sort of hang out at the end. Take that middle thing, cut it in half. That got me negative 1. Square that thing, which got me just positive 1. Add and subtract, right? That lets me take the original 2 pieces plus the added thing, like the thing that I added as opposed to subtracted. Those 3 become this sort of nice perfect square. I have that left over. Put the 4, right, distribute the 4 back out, combine like terms, got my answer. Okay, so that is that.